While the modern world depends on constant electricity, the Amish thrive without it and barely miss a beat. Their daily systems are practical, efficient, and built to work in any situation. What they rely on instead keeps life steady, calm, and surprisingly well powered, proving you don't need electricity to live comfortably. When the sun sets over an Amish farmhouse, there's no flipping of light switches or fumbling for remote controls. Instead, the soft hiss of a kerosene lamp fills the room as families settle in for the evening. The Amish have mastered the art of lighting their homes using pressure or mantle-style kerosene burners that produce a surprisingly bright and steady glow without a single volt of electricity. These aren't your grandmother's flickering oil lamps that dance shadows across the walls and smell like a mechanic's garage. Modern kerosene lamps used by the Amish are engineered for efficiency, burning clean, and producing light that's actually bright enough to read by without squinting like you're trying to decipher ancient hieroglyphics. The secret lies in the pressure system. These lamps force kerosene through a small nozzle under pressure, creating a fine mist that burns with remarkable brightness. The mantle, a delicate mesh fabric treated with chemicals, glows white-hot when heated and amplifies the light output dramatically. One properly maintained kerosene lamp can illuminate an entire room with the brightness of a 60-watt bulb, which is pretty impressive when you consider there's nothing plugged into a wall. Amish families don't just grab one lamp and call it a day. Though they keep entire stockpiles of extra wicks, mantles, and fuel stored away in their basements and sheds. Winter nights are long, and running out of light in January when the sun disappears by 5 in the afternoon is nobody's idea of a good time. Some folks spend more on their electricity bill than the Amish spend on lamp fuel all year, which really puts a new spin on the phrase living in the dark ages. What makes these lamps even more practical is how Amish families have adapted their homes to maximize their usefulness. Many mount their lamps on sliding wall rails, an ingeniously simple system that lets them move light around a room without carrying the lamp itself. Need to light up the dining table for supper? Slide the lamp over. Working on mending clothes near the window? Slide it back. It's like having track lighting, except the track is a brass rail and your dimmer switch is the fuel valve. This mobility means families don't need to own 20 lamps scattered throughout the house. 3 or 4 strategically placed lamps on rails can light an entire home efficiently. There's also an unexpected bonus that most people don't consider. Kerosene lamps produce gentle, radiant heat as they burn. During those bitter winter months when frost creeps across the windows, the warmth from a lamp isn't just pleasant. It actually reduces how much firewood needs to be burned in the stove to keep the room comfortable. The glow also creates an atmosphere that's hard to replicate with harsh electric bulbs. Studies show that warm yellow light actually helps people sleep better than blue-tinted electric bulbs. So maybe the Amish have been onto something this whole time, while the rest of us have been giving ourselves insomnia with LED screens. The fuel efficiency is remarkable too. A single gallon of kerosene can power a lamp for roughly 200 hours of burn time. For a family using 3 lamps each evening for about 4 hours, that's nearly 17 days of light from just 1 gallon lighting solves one problem. But what about keeping food fresh in the summer heat? Most people can't fathom keeping food fresh without electricity, but the Amish have been doing exactly that for generations using propane-powered refrigerators that work on a completely different principle than the humming electric box in your kitchen. These refrigerators use absorption cooling, a process that sounds like something from a chemistry textbook, but is actually beautifully simple. Instead of an electric compressor cycling refrigerant through coils, propane absorption fridges use heat to drive a chemical process involving ammonia, hydrogen gas, and water. Yes, you read that right. Heat creates cold. It's the kind of backwards logic that makes perfect sense once you understand it, like how adding salt to ice makes it colder. The absorption cooling cycle works because ammonia dissolved in water can evaporate at low temperatures when exposed to hydrogen gas. As the ammonia evaporates, it absorbs heat from inside the refrigerator, creating that cold environment we need to keep milk from turning into cottage cheese. The propane flame heats the ammonia water solution in the generator, separating them. The ammonia vapor then travels through the system, condenses, and evaporates again in the presence of hydrogen, pulling heat out of the fridge box. The beauty of this system is its simplicity. There are no moving parts except for the flow of fluids, which means these refrigerators can run for decades without breaking down. Electric fridges seem to die right after the warranty expires. But propane fridges are like that one truck from the 1980s that refuses to quit, no matter how rusty it gets. Amish families typically maintain large propane tanks outside their homes, often holding 500 to 1,000 gallons. These tanks supply not just the refrigerator, but also cooking stoves, water heaters, and propane lanterns throughout the house. The propane delivery truck becomes a familiar sight in Amish communities, making rounds every few months to top off tanks. The fuel consumption is remarkably economical. A typical propane fridge uses about 1.5 to 2 pounds of propane per day, which translates to roughly 2 gallons per month. For a family keeping their food fresh year-round, that's only about 24 gallons annually. When summer temperatures soar into the 90s, these propane refrigerators really prove their worth. Electric fridges struggle during heat waves, working overtime and driving up power bills. Propane units maintain consistent temperatures regardless of outside conditions. Some resourceful Amish families even pair their propane refrigeration with old-fashioned ice blocks during peak harvest season when the fridge is packed with vegetables, fresh milk, and preserved goods. The combination stretches propane supplies and ensures nothing spoils during those critical weeks when the garden is producing faster than the family can eat. The versatility of propane extends beyond refrigeration too. Propane-powered lights provide bright illumination in kitchens and workshops. These fixtures burn with a white, steady flame behind a glass globe and can light up a workspace as effectively as any fluorescent tube. Some Amish shops are so well lit with propane fixtures that visitors forget they're in a building with no electrical service until they instinctively reach for a light switch that doesn't exist. The independence that propane provides cannot be overstated. When power grids fail during storms and modern homes sit in darkness with refrigerators slowly warming up, Amish families continue their routines uninterrupted. But propane isn't the only way the Amish keep things cold. The only product we'll ever promote on our channel is a book by Claude Davis, a veteran prepper, about 126 superfoods and preservation methods from crisis times like the Great Depression and wartime that are impossible to find elsewhere. We decided to promote his book because we are the last generation able to share these techniques and superfoods to our children or grandchildren. It would be a shame to see this information about highly nutritious foods and preservation methods to survive crises disappear. You can also find a book about herbal remedies from Nicola Pelian on their store. If you're watching this on TV, you can look up our channel, Frugal Solutions, on your phone or tablet and find the books by clicking the link in our channel description or any other video description. Long before electric freezers hummed in every kitchen, ice houses were the standard method of food preservation, and the Amish have refined this practice into a reliable science that would impress any engineer. The process begins in January when ponds and small lakes freeze thick enough to support the weight of horses and cutting equipment. Amish men venture onto the ice with special saws designed to cut through frozen water, carving out blocks that typically measure about 18 inches square and weigh anywhere from 75 to 100 pounds. These massive chunks are hauled by sled to insulated storage buildings called ice houses, where they're packed methodically in sawdust to prevent melting. The sawdust acts as a natural insulator, trapping air pockets that slow heat transfer dramatically. The construction of an ice house itself is crucial to success. These buildings are typically built partially underground, where earth temperatures remain cooler year-round. Thick wooden walls, often double-layered with sawdust or wood chips packed between them, provide additional insulation. The roof usually features a steep pitch to shed rain quickly and prevent water from seeping into the structure. Ventilation is carefully controlled, with small adjustable vents near the roof peak that release any heat that manages to penetrate the building while keeping warm outside air from flowing in. A well-constructed ice house can keep ice frozen for 6 to 10 months, meaning blocks cut in January remain solid through August or even September in northern regions. Ancient Romans stored ice in underground chambers and charged premium prices for cold drinks in summer, so the Amish are basically running a time-tested business model without the markup. The size of ice blocks matters more than most people realize. Larger blocks have a lower surface area to volume ratio, which means less exposed surface for heat to attack. A 100-pound block melts much slower than two 50-pound blocks, even though the total ice mass is identical. Amish families layer their ice carefully, placing the largest blocks in the center of the pile where they're most protected and smaller pieces toward the edges where they'll be accessed first. As summer progresses and the outer blocks shrink, families work inward, always leaving the biggest reserves for late season when the heat is most intense. When it's time to use the ice, families chip or shave portions rather than removing entire blocks. Dairy products benefit enormously from ice house storage. Fresh milk straight from the cow sits at around 101 degrees Fahrenheit and needs to be cooled quickly to prevent bacterial growth. Amish families submerge milk cans in ice water baths, often in dedicated spring houses or milk houses adjacent to the barn. The ice-cold water drops the milk temperature to below 40 degrees within an hour, keeping it fresh for days. A block of pond ice can keep a milk can cold for an entire day, even in July heat. Meanwhile, the Amish are over here playing the world's longest game of don't let the ice cream melt and winning every single summer. The environmental wisdom of ice houses shouldn't be overlooked either. This preservation method uses zero fossil fuels, produces no emissions, and relies entirely on renewable winter cold. Food stays cold, but there's another resource farms can't survive without. Water is the lifeblood of any farm, and Amish communities have long understood that harnessing wind power offers a reliable, sustainable solution that works whether the electric grid exists or not. The tall windmills that dot Amish farmland aren't decorative relics from a bygone era. They're highly functional pieces of engineering designed to pump groundwater from wells deep below the surface up into elevated storage tanks where gravity can distribute it throughout the farm. These windmills are specifically designed with oversized blades, sometimes spanning 8 to 12 feet in diameter, which allows them to capture even the gentlest breezes and convert that movement into pumping power. Unlike the sleek modern wind turbines built for generating electricity, traditional farm windmills are built for torque and consistent pumping action rather than high-speed rotation. The mechanics are elegantly simple. Wind catches the blades and rotates a central shaft connected to a vertical pump rod that extends down into the well below. As the windmill wheel turns, the rod moves up and down, operating a cylinder pump at the bottom of the well shaft. Each stroke lifts water up through a pipe to the surface, where it flows into storage tanks positioned at the highest point on the property. Gravity then provides natural water pressure throughout the distribution system, sending water to barns, garden spigots, and indoor hand pumps without requiring any powered pumps along the way. The elevated storage tanks, often holding 500 to 1,500 gallons, ensure water availability even when wind speeds drop or the air goes completely still for a day or two. What makes these windmills particularly clever is their ability to function in low wind conditions that would leave modern turbines motionless. The large blade diameter means even a 5-mile-per-hour breeze can start the wheel turning, and the mechanical advantage of the gearing system means relatively slow rotation still produces effective pumping. In regions where wind patterns are reliable, a single windmill can pump thousands of gallons daily without human intervention, maintenance, or fuel costs. The initial investment in a quality windmill is significant, running several $1,000s for the tower, blades, and pump mechanism, but the operational cost over the next 30 to 50 years is essentially zero beyond occasional greasing of the gearbox and replacing worn bearings. Utilities would charge you that much just for asking them to run a water line out to your property, and then they'd send you a bill every month for the privilege of using what you already paid for livestock depend entirely on consistent water access, especially dairy cows that can drink 30 to 50 gallons per day during hot weather. A herd of 20 cows requires up to 1,000 gallons daily during summer, a demand that would be expensive and complicated to meet with trucked-in water or manually hauled buckets. The windmill handles this demand automatically, pumping water whenever the wind blows and storing the surplus for calm periods. Garden irrigation benefits similarly. Amish families maintain large vegetable gardens that feed their households year-round, and these gardens require steady watering during dry spells. The backup systems reveal the Amish commitment to practical redundancy. When wind speeds drop to nothing during those rare extended calm periods, manual hand pumps positioned near the windmill connect directly to the same well and water lines. A few minutes of vigorous pumping can fill buckets for immediate needs or partially refill storage tanks. Emergency services get stretched thin trying to deliver water to thousands of properties, while Amish farms just keep pumping away like nothing happened, which probably makes the neighbors wonder if they chose the wrong lifestyle. The environmental benefits extend beyond zero emissions. Wind-powered pumps have no noise pollution, require no fuel extraction or transportation, and when they eventually wear out after decades of service, most components can be recycled. Water flows through the farm, but inside the house, there's a whole different set of challenges to solve. Step into an Amish kitchen, and you'll notice something immediately. There's no electric mixer humming on the counter, no food processor chopping vegetables at lightning speed, and definitely no instant pot counting down with digital precision. Instead, the counters and cabinets hold an impressive array of hand-cranked tools that look like they belong in a museum, but function with surprising efficiency and durability. These tools represent more than just nostalgia or tradition. They're highly engineered devices built from metal gears and cast iron components designed to last for decades of daily use without breaking down or needing replacement parts shipped from overseas. The crank-powered egg beater is probably the most recognizable of these tools, featuring two interlocking beaters driven by a hand crank and gear system that can whip eggs or cream into peaks just as effectively as any electric mixer. Meat grinders are another kitchen staple, bolting securely to the edge of a table or counter and using a large crank handle to force meat through cutting blades and grinding plates. These grinders handle everything from making sausage to grinding scraps for hamburger, and they process meat with impressive speed when you've got a strong arm and a steady rhythm going. The different grinding plates allow for coarse or fine grinds, depending on what's being prepared. Apple peelers demonstrate the same mechanical ingenuity, using a 3-in-1 design that peels, cores, and slices apples into perfect spirals with just a few turns of the crank. During harvest season, when bushels of apples need processing for canning, drying, or baking, these hand-crank peelers save countless hours of tedious knife work. Electric gadgets might be faster until they overheat and shut down for 20 minutes to cool off, which is basically the kitchen equivalent of your teenager promising to do chores in just a minute, and then disappearing. The grain mills deserve special mention because they showcase just how much processing power can be generated by human effort and good gears. Hand-cranked grain mills with hardened steel burrs can grind wheat, corn, oats, and other grains into flour of varying coarseness. Freshly ground flour tastes noticeably better than store-bought because the natural oils haven't oxidized or gone stale during storage and shipping. Amish families grind flour as needed rather than storing large quantities, ensuring every loaf of bread, batch of biscuits, or pie crust is made with the freshest possible ingredients. The grinding process takes some elbow grease, certainly, but most mills are geared efficiently enough that children can help with the task, making it a family activity rather than a solitary chore. What makes these hand tools particularly practical is the control they provide over texture and consistency. When you're cranking an egg beater by hand, you can feel the resistance change as eggs thicken into foam. You can speed up or slow down instantly based on what the recipe needs. Electric mixers run at preset speeds that might be too aggressive for delicate batters or too slow for heavy doughs, but hand tools respond immediately to the operator's judgment. This tactile feedback helps cooks develop better instincts about when something is properly mixed, ground, or beaten. The durability of these hand-cranked tools is legendary. While electric appliances average maybe 5 to 10 years before motors burn out or plastic parts crack, metal hand-cranked tools routinely last 30, 40, or even 50 years with minimal maintenance. The gears might need occasional oiling, and cutting blades may require sharpening, but these are simple tasks that anyone can learn. Many Amish families use tools that were wedding gifts to their grandparents, still grinding meat and beating eggs with the same reliability they had when they were new. Modern kitchens are full of gadgets that promise to save time, but somehow everyone's still too busy to sit down for dinner together, which suggests maybe all that saved time is disappearing into TikTok videos and Netflix binges. The centerpiece of an Amish home isn't a television or a fancy entertainment system, It's a massive cast iron cook stove that serves double duty as both the family's primary heat source and the kitchen workhorse where every meal gets prepared. These wood-fired stoves are engineering marvels that would make modern appliance designers jealous, combining heating, cooking, and even food warming into a single fuel-efficient package. A well-designed cook stove can warm multiple rooms while simultaneously baking bread, simmering stews, and keeping pots of coffee hot for hours. Temperature control on these stoves requires skill and attention rather than digital thermostats and preset buttons. The size of the fire, the type of wood burning, and the adjustment of draft vents all combine to determine how hot the oven gets and how much heat flows into the surrounding rooms. Hardwoods like oak and maple burn hotter and longer than softwoods, making them ideal for maintaining steady cooking temperatures. Amish cooks learn to read their stoves instinctively, knowing exactly how much wood to add and when to adjust the dampers to keep the oven hovering around 350 to 375 degrees for baking. Learning to cook on a wood stove is a bit like learning to drive a stick shift. Lots of trial and error at first, but once you get it, you wonder why anyone needs all those fancy automatic features. The warming shelves positioned above the cooktop stay warm from rising heat, but don't get hot enough to burn food, making them perfect for keeping finished dishes at serving temperature. During winter months, the cook stove becomes the heart of the household in ways modern homes rarely experience. Families gather around it for warmth, children do homework at the kitchen table bathed in radiant heat, and wet clothes and boots dry on racks positioned safely nearby. The efficiency of using one heat source for multiple purposes cannot be overstated. Modern homes waste tremendous energy keeping a furnace in the basement and a separate stove in the kitchen, each burning fuel independently. Meanwhile, modern stoves seem to need replacing every 10 years, which makes you wonder if planned obsolescence is just a fancy term for, we made it cheap so you'd have to buy another one. The stoves themselves are built to last generations, with many Amish families cooking on stoves that are 50, 60, or even 100 years old. Replacement parts like grates and door gaskets are readily available, and basic maintenance keeps these stoves running indefinitely. Warmth and food are essential, but clean water flowing through the house requires its own ingenious solution. Sharing resources makes practical sense when you're living without electricity, and the Amish have developed community water systems that supply multiple households from a single source without requiring a single electric pump. These gravity-fed systems work on a beautifully simple principle that civil engineers have used for centuries. Water flows downhill naturally, and if you can store it at elevation, gravity provides all the pressure needed to push it through pipes and into homes. Several Amish families will sometimes pool their resources to build a large water tank on the highest point of land in their area. And from there, water flows downward through underground pipes to each participating household. The beauty of this arrangement is its complete independence from external utilities. There are no monthly water bills, no reliance on municipal systems that can fail during emergencies, and no electric pumps that stop working when storms knock out power. For every foot of elevation difference between the tank and the outlet, you gain roughly 0.43 pounds per square inch of pressure. A tank positioned 100 feet above a house creates about 43 pounds per square inch of pressure at the tap, which is perfectly adequate for sinks, showers, and all normal household uses. Maintenance of these community systems becomes a shared responsibility handled through organized workdays. When pipes need repair, tree roots need clearing, or the tank requires cleaning, families gather to handle the work together. This cooperative approach distributes both the labor and the cost across multiple households, making major projects manageable for everyone involved. The Romans built aqueducts using the same gravity-fed principle over 2,000 years ago, and many of those are still standing, which suggests maybe simpler engineering actually works better than complicated systems that need constant updates and tech support. Children growing up in these communities learn valuable lessons about cooperation, shared responsibility, and how infrastructure actually functions rather than just assuming water magically appears when you turn a faucet. Winter presents unique challenges that Amish communities have learned to manage through experience and preparation. Tanks must be insulated or partially buried to prevent freezing, and an extreme cold, slow water flow through pipes can freeze solid. Many systems include small recirculation loops that keep water moving through critical sections of pipe, preventing ice formation. Some communities enhance their systems with multiple tanks at different elevations, creating redundancy and ensuring water supply even if one tank needs servicing. The reliability of these community water systems has been tested repeatedly during natural disasters when modern infrastructure fails. Floods, ice storms, and severe weather that leave entire regions without power barely affect Amish communities with gravity-fed water. Water flows naturally through homes, but many tasks require power of a different kind. The sound of compressed air tools in an Amish woodworking shop is almost identical to what you'd hear in any modern workshop, yet there's not a single electric outlet in sight. The Amish have found a clever workaround that lets them use powerful pneumatic tools while staying true to their principles about avoiding electricity. Large diesel or propane-powered air compressors positioned outside the workshop create compressed air that's stored in tanks and distributed through pipes running throughout the building. This compressed air powers sanders, drills, saws, nail guns, and practically any tool that would normally plug into a wall. The theological reasoning behind allowing pneumatic tools while prohibiting electric ones might seem confusing to outsiders, but it makes sense within the Amish framework of acceptable technology. Different Amish communities have varying rules, but many permit compressed air because it represents stored mechanical energy rather than a direct connection to the outside electrical grid. The compressor itself runs on diesel or propane fuel that the family controls directly, maintaining their independence from external utilities. Setting up a pneumatic workshop requires significant initial investment but pays dividends in versatility and reliability. A quality diesel compressor capable of running multiple tools simultaneously costs several $1,000s, and the piping system adds additional expense. However, once installed, the system operates for decades with minimal maintenance beyond oil changes and occasional belt replacements. Carpenters using electric tools often joke about batteries dying at the worst possible moment, but pneumatic tools keep running as long as the compressor tank stays pressurized, which is basically the mechanical equivalent of a gas tank that refills itself while you work. Air tools themselves tend to be less expensive than their electric equivalents and last longer because their internal mechanisms are simpler. The performance of pneumatic tools impresses even skeptics familiar with electric equipment. Air-powered impact wrenches generate tremendous torque. Pneumatic sanders spin at high speeds for smooth finishing work, and air nailers drive fasteners with consistent force. The safety advantages also deserve recognition. Compressed air tools eliminate the fire and shock hazards associated with electric equipment. There are no sparks from worn motor brushes, no risk of electrocution if a tool gets wet, and no overheating motors that can ignite sawdust. Amish craftsmen have become remarkably skilled at building furniture, cabinets, and structures using these pneumatic tools. The quality of Amish-made furniture and buildings is legendary, proving that avoiding electricity doesn't mean sacrificing craftsmanship or productivity. Power tools handle the heavy work, but daily household tasks need water delivered efficiently throughout the home. Running water might seem impossible without electric pumps, but the Amish have perfected gravity-fed plumbing systems that deliver water throughout their homes using nothing more than elevation and physics. The basic setup involves installing a large water tank in the attic, loft, or highest point of the house, then running pipes downward to all the sinks, showers, and fixtures that need water supply. Once the tank is filled, either manually with buckets by windmill pump or through a community water system, gravity does all the work of pushing water through the pipes and out the faucets. The filling process varies depending on the household's water source and available labor. Some families pump water into the attic tank using hand pumps connected to wells, a task that builds arm strength and provides daily exercise. Others use windmill-pumped water that fills the tank automatically whenever wind is blowing. The most convenient setups connect to community gravity-fed systems where water pressure from a higher elevation tank simply refills the household tank through normal pipe flow. A typical household tank holding 200 to 300 gallons provides plenty of water for cooking, cleaning, bathing, and drinking for a family between refills. Water pressure from these gravity systems might not match the force of a modern municipal supply, but it's more than adequate for comfortable living. Showers deliver a steady stream, Sinks fill at reasonable speeds for washing dishes, and toilets flush reliably. Some modern low-flow fixtures actually work better with gravity-fed pressure than with high-pressure municipal water, which is ironic considering those fixtures were designed to save water in homes that have way too much pressure to begin with. The simplicity of gravity-fed plumbing means there are almost no failure points in the system. There are no pumps to burn out, no pressure switches to malfunction, and no electronic controls to glitch. Many Amish families enhance their systems by insulating the attic tank so it retains heat absorbed from sun-warmed attic spaces during the day. In summer, this can provide pleasantly warm water for washing without requiring any fuel to heat it. During winter, insulation prevents the water from freezing even when outdoor temperatures plunge well below zero. The maintenance requirements are minimal compared to pressurized electric systems with no annual pump inspections or pressure tank bladder replacements needed. When power outages leave modern homes without water because electric pumps stop working, Amish households continue functioning normally. The knowledge that clean water will flow regardless of external circumstances provides a level of self-sufficiency that resonates deeply with Amish values. Individual solutions work well, but the Amish approach to heavy labor reveals something even more fundamental. The famous Amish barn raising represents far more than just an efficient construction method. It reveals the core philosophy that makes living without electricity not just possible, but genuinely sustainable. When a family needs a new barn, dairy facility, or major structure, the entire community shows up with tools, materials, and coordinated effort that transforms what would be a months-long project into a single day's achievement. Dozens of men work simultaneously on different aspects of construction, with experienced craftsmen handling critical framing while others prepare materials and manage logistics. This approach completely inverts modern construction logic that relies on heavy machinery, small crews, and extended timelines. A typical barn raising might involve 50 to 100 men working together for 10 to 12 hours, accomplishing what a professional crew using excavators and cranes would take weeks to complete. The community method builds social capital and mutual obligation alongside the physical structure. When you help raise your neighbor's barn, you know they'll show up when you need a building constructed. The division of labor during these events showcases impressive organizational skill. Older, experienced builders handle precise joinery and load-bearing connections. Middle-aged men with strong backs lift heavy beams into position. Younger men and teenage boys run materials and assist wherever needed. Modern construction sites have safety meetings that last longer than some Amish crews need to frame an entire wall section, which really makes you wonder how we convinced ourselves that more planning meetings equals better results. Meanwhile, women organize massive meal preparation, cooking enough food to feed the entire work crew throughout the day. The economic implications extend far beyond the immediate project. When you don't need to pay contractors, rent equipment, or purchase specialized machinery, construction costs drop dramatically. The family receiving the new barn typically provides all materials, but the labor is freely given by the community. This reciprocal nature means that over a lifetime, every family both gives and receives this labor many times. Beyond construction, this model extends into daily farm work during critical seasons, with neighbors rotating from farm to farm to help with harvesting and planting. The stress reduction alone is valuable beyond measure. Modern farmers operating massive machinery often work grueling hours racing against weather with no backup support. Amish farmers know that if equipment fails or the workload becomes too much, help is just a short walk away. The Amish approach proves that human energy, properly organized and collectively applied, can replace almost any machine when backed by strong social structures. The Amish remind us that living without electricity doesn't mean living without comfort. Their days run on habits that are dependable, low stress, and built around tools that never break down when you need them most. Instead of chasing constant convenience, they focus on systems that give them control, stability, and peace in every season. Their homes stay warm, their food stays fresh, and their work gets done because everything is designed to function simply and reliably. In the end, their way of life proves that true security doesn't come from outlets or switches. It comes from knowing how to live well with the basics and still thrive.